right, the final example that we're going to look at in section 10.3 is we're going to look at our present value formula. Right, our present value formula is going to give us an idea of if we have a goal for later on down the road, what do we need to do now, right? So you might wonder about the amount of money to deposit in an account today to have a certain amount of money in the future. The principal that would have to be invested now is called the present value. So looking at this formula, P is our principal, that's our present value. A is our amount that we want at the end. R is still our interest rate as a decimal. T is still our time. N is still our number of compoundings per year. But we're going to use a slight variation. So what we've done is we've taken our original compound interest formula and just kind of rearranged to what we're solving for, right? So to kind of explain where that comes from, right, our original compound interest formula, A equals P times 1 plus Rn to the nt. Well, if I decide that I want this P all by itself, I have to divide the rest of this stuff, right? So we're going to divide by this entire, right, thing in parentheses and the exponents that go with it. Well, whatever we do to one side, we have to do the same thing to the other side. Right? So essentially everything on this side cancels out, and what we're left with is P all by itself, and then A divided by the rest of the parts from our compound interest formula. That's exactly where this formula comes from. That's how we generate this. Again, you don't need to memorize the formulas or how they're generated by any means. We just have to know how to use them. So in the example that we're going to look at, we'll talk about how we can use this formula. So we are told to use the present value formula to find the following. Will would like to invest enough money in a certificate of deposit, CD, now to pay for his daughter's college expenses in 6 years when she finishes high school. If Will estimates that he will need $30,000 in 6 years, how much should he invest now in a CD that has a rate of 2.5% compounded quarterly? All right, so our present value formula, P equals A divided by our big set of parentheses and exponents. 1 plus R over N to the NT power. All right, let's make a list here. All right, A, our amount that we want in 6 years is $30,000. T, our time, is 6 years. Our interest rate is 2.5%. 0.025. Compounded quarterly, right, means again that N is 12. All right, so we're going to plug all of this stuff into our formula here. P equals 30,000 divided by 1 plus 0.025 over, oops, I said that N equals 12. That is definitely not correct. Compounded quarterly. Compounded quarterly, there's only 4 quarters per year. I was stuck on monthly from one of the last examples. That it should definitely be a 4. So if you wrote down a 12, please make sure you correct it. I apologize for that. Okay. So there's 0.025 divided by 4, and then raised to the 4 times 6 power. Okay. Under here, I did put in some calculator help again. So we're going to use this calculator help to enter this stuff into our calculator. Right, this y to the x, remember, is also our caret button. Right, so depending on the type of calculator you have, you might be seeing a caret button instead. All right, so we're going to take 30,000. Make sure we got the right number of zeros in there. We're good. Divided by. That doesn't have to be in parentheses because that's just our plain old numerator. Right, and then parentheses definitely down here. 1 plus 0.025 divided by 4, parentheses to close that off, caret button, parentheses, 4 times 6, or you could shorten that last step after the caret button. You could just enter the number 24. That's totally up to you. All right, then we hit equals 25833.29562. All right, so I'm going to copy that in here. 25833 0.29562. All right, so we want to take this answer and we want to round it off. So we are going to get $25,833. Right, 0.29. So what we need to decide, is this going to stay 29 cents or is it going to turn to 30 cents? Well, in this case, that's going to round up. We're going to get 0.30. Right, the 5 makes that 9 go up, which then makes the 2 go up. 29 rounds up to 30 cents. Right, so again, in this case, we're using our present value formula. Our present value formula is if we're looking for the original amount to invest. So he wants to have $30,000 in 6 years. That means that if he were to invest today using the information that's provided, he should invest amount of $25,833.30, and then that will give him his investment that he's looking for at the end.